So we're not going to get too in depth with this in my class, but you can solve equations with radicals in them, and it's really not that bad of a process. It's just something that, in the interest of time, we're just going to spend a very brief lesson on. The basic idea with these is that you want to get the radical by itself. So if I'm looking at this first problem here, just like you would solve a regular equation, I'm going to subtract my 2 from both sides and get that out of here. When I do that, I get my square root equals 4 there. And when you get to this point, you have to ask yourself, I need to get to x. X is trapped inside the radical here. How do I cancel that radical out? And the way you do that is by squaring both sides of your equation. So you square both sides and those cancel. You get 4 minus 6x is equal to 16. And from there, you're just solving a regular algebra problem. So you subtract your 4, you divide by -6. You're going to end up with x equals -2. That's the solution to the equation, and if you plug it back in, you'll see that it does actually work. So you get the radical by itself, and you cancel it out by raising it to the right power. On my second problem here, when you go to start the problem, you do your -10. You end up with the square root equals -5. This is actually kind of a problem on the second one, and this is what my note above that I really didn't mention yet means. With square roots, when you do them, you always do the square root, you give a positive answer. It's just what you do. When square roots are defined to just be the positive solution. So here we're taking the square root of something, but we're saying it's equal to a negative. That's bad, and there is no solution to that. No real solution to this problem here. Because when we define square roots, we say they have to be positive, or non-negative at least. So if you see your, kind of like what we do with absolute values actually, first semester, when we saw that absolute value bar is equal to a negative, we said no solution. It's the same sort of thing. When you see a radical, with an even index anyway, equal to a negative, you say no solution. And on our last problem here, the radical is already by itself, which is great. No extra work to do there. We're just going to raise both sides this time to the third power because we want to cancel out that cube root. We get x plus 2 equals 4 to the third power is 64. You solve the equation, you get x equals 62. And that's the end of that.